I've invited our first three speakers to give their views on how national and international policies influence and are influenced by energy storage. So let me introduce Patrick Clerens. Patrick is the Secretary General of the European Association for the Storage of Energy. It's called EASE. Patrick spent more than 20 years specialising in European affairs in Brussels, representing several European associations in the climate and energy fields. In his work for EASE, Patrick promotes the role and importance of energy storage systems. I have invited Patrick to talk to us about the role of longer duration energy storage and how it impacts on European energy storage policy. So welcome, Patrick. Please turn on your microphone and over to you.
Thank you, Anthony. Thank you very much for the kind words and for the invitation. I'm very happy to see that the IFBF is now online and that we have the chance to exchange and to learn from each other in this virtual world. And I find it very nice that you managed to adapt fast enough to have it happen. I will speak today about EASE and about European Union activities regarding to storage and specifically for longer duration energy storage. And I will start directly given the time which have been allocated. Could I have the next slide, please? So these are the EASE members. EASE is a European association of roughly 50 companies where we represent the whole chain. So we represent research centers, component suppliers, material suppliers, also full equipment, utilities, developers, distribution system operators, transmission system operators, consultants. Everyone is in there, which on one side is quite challenging when you ask these very interesting questions of who should own energy storage, if regulated entities have the right to do so or only not regulated entities. And so it's very tricky sometimes, but very, very positive. And when we have a common position, which is always happening, then we have a very strong position because it represents the whole sector. Could I please have the next slide? So here on this slide, you see basically the energy policies in Europe and the evolution since last year when I announced that we had the clean energy package and that we have national energy and climate plans, which are published in Europe, is that now we have the European Green Deal and the next generation EU. And maybe just to look at it, and you can click on the link in the presentation once you will receive it, you see that the European Green Deal is pushing a lot for renewables and it's pushing a lot for batteries and for more funding. It will also give the European Commission for the first time a real revenue by having the carbon adjustment mechanisms. It was called carbon border tax previously, now it's a mechanism, not a tax anymore. And I will take maybe 30 seconds to tell you as a European, I'm very happy that we managed in the European Union to create for the first time a European Union recovery plan, which is called Next Generation EU. And it's the first time that we do these steps, which are needed if you want to go together, of debt mutualization to some extent, of solidarity between the member states. We see that there will be funds available on the EU level which will be given to companies in specific countries. Governments will be able to tap into investment and so on and so on. So we see that we're moving further into integration of the European Union, and that's a pity that the UK is leaving at this moment, but we will still keep the contact. On the next slide, you see that these different funds and the funding is basically pushing or is supporting the policy changes which are ongoing, which means that we have in the European Union the new battery regulation, which is under discussion for the moment. And this battery regulation will be quite interesting because it will regulate also the environmental impact of batteries, which means that the batteries with a low environmental impact will have a better head start. We will see that it will look at the greenhouse gas emissions, it will look at the sourcing, but also the second life of batteries, the ownership. The question is such a battery then, after it has been used, let's say in a car, is it then owned by the car manufacturer, by the one who bought the car, or by the person who at the end will get this battery? but not to recycle, but to use it. And then is it a waste, is it not a waste, and so on. So a lot of points which are looking in this European Union regulation, this new regulation, which is under proposal for the moment. On the next slide, you see a lot of support for research and development. And there's the European Battery Alliance, which is basically a forum in which the European battery world comes together, which is not specifically linked to one battery type, but it has been driven from the idea pushed by the Vice President Šefčovič that we will have in the future, we don't want to depend in the future on Asian batteries compared to today's Middle Eastern oil for transportation. So in order to get an own battery production facilities in Europe and to push own knowledge, we have this European Battery Alliance as a platform for us created. This was supplemented by two activities. One is a European Technology and Innovation Platform called Batteries Europe, and the other one is called Battery 2030 Plus, which is basically looking more in basic research and more fundamental research than the others, where Batteries Europe is more looking in the R&I research and innovation part, so getting into the market. But what is interesting is also that this is now complemented by a so-called European Partnership on Batteries, and if you will click on the link once you have the slides, you can be directly redirected there, where you could sign up to if you want to. It's a link available, where money will be ring-fenced, several hundreds of millions of euros. For the discussion in the moment is about 200 to 300 million euros in the first 2 years. In 2021 and 2022 will be spent on these European Partnership on Batteries, where research and innovation of batteries, all kinds of batteries, will be put together. So it's, you see there are a lot of initiatives, a lot of funding, really money flowing into this, because we want the European Union to generate an environment for batteries development, meaning also the research centers, the materials, and everything related to it. It is supported on the next slide. You will see it by the European Investment Bank, which is available to lend over 1 billion euros for the battery industry in 2020. And we see that the Commission allowed public support. So normally in Europe, you may not support industries because we have a single market without hampering the competition of these. So state aid is very limited. But in the vehicle used, which is used there, which is called IPCEI, Important Project of Common European Interest, these projects are allowed to be funded by member states. So there is an IPCEI on batteries. So batteries has been identified, and the member states who participate are therefore being allowed by the Commission to give state aid up to 3.2 billion euros for these battery IPCEI. And the aim of this is to create up to 1 million jobs in the ecosystem of batteries with more than 200 billion euros economy behind it. So it's very challenging. We have seen that it's always difficult if a government or here the Commission starts an idea, but we have also seen with the Airbus that it's feasible to come together. So this is one step forward to create this battery systems in Europe. On the next slide, you see what's happening on research. And we made these battery initiatives very strong and broad. So it will also look at flow batteries for smaller and bigger devices. We'll look at components. And I mean, the challenge which you're facing in the battery and the flow battery sector is not that it's not working. The challenge is that the prices are too high. The challenge is that we do not have standard membranes rolled out by mass production. We do not have the stacks produced by mass production. We don't have this normation process far enough. And we need to get all this done in order to get the cost down and to have the rollout. We need to get also the density of the, let's say, vanadium in the electrolyte from, I don't know how much it's now, 1.3 to over 2.4 moles. So we need to increase the density in all this. If we don't manage to get the costs down, it will not work. And all this, which has been presented now, is aimed at reducing the cost, at standardizing, at getting the technology done. And we see that we are market leaders in several sectors of the battery value chain, but it's not enough. So we want to enlarge this. On the next slide, I wanted to share with you a publication which was done where EASE contributed about the need for flexibility. You can maybe not see it because it's very small. I hope you can zoom in. On the left side, you see the flexibility needs in terawatt hours. And the first box, which is roughly 200 terawatt hours, is business as usual in 10 years. So Europe is expected to need as flexibility roughly 200 terawatt hours in roughly 10 years. If you look at 2050, and these are the two scenarios on the right, there is a 1.5 degrees Celsius scenario, the ambitious scenario of the Paris Agreement, and the 2 degrees Celsius scenario, which is the right-hand side. And both are roughly around 600 terawatt hours in 2050. So the challenge is recognized. There is an identification of what we need, and we're now hoping to get the technologies and the roadmap and the revenue streams to get there in time. I said it's recognized because we have seen very clear statements in the last years. Last year, the European Union in the Electricity Directive stated it is necessary to make progress in seasonal energy storage. Boom, first time that you really see that we are going further than the energy optimizations through lithium-ion or short-term batteries. And then we see that we also have the Commission in the long-term strategy was mentioning that there are different technical solutions to compete for storing electricity over time frames between seconds or fractions of seconds and even seasons. So we see this is recognized. So all this shows that on one side, there are a lot of changes, which is on the next slide. Oh, sorry, the slide didn't change. Can you, yes, this one, thank you. So it's recognized, you can go to this a bit later, it's recognized in text that we need to have more than only seconds and milliseconds, but also go to seasons and weeks. And on the next slide, to have recognized that there are many changes in Europe, but we also identified in EASE challenges. And here are the last slides. Basically, we see that if you want to have investment security, and this is not a new slide, we're claiming this since years, we're asking for longer term contracts, for longer term system service contracts. This is on the next slide, please. This is something which is not happening. I'm not sure this is the right slide. I don't know if you see now the point 5 of my slide, which should have come after the previous slide. So I will just speak to it while this is sorted out. You should have the PowerPoint and the PDF, so in both versions you should have it. So one of the main points is the long-term contracts, which are absolutely needed, and this is not recognized now. So we're pushing very strongly on European level with the TSOs to create a framework for longer-term contracts. Then on the next slide, we see that there is still existing challenges regarding, thank you very much. These are the long-term contracts. And on the next slide, you see the challenges with the grid fees. I always say, and I say this since years, could I please have the next slide, that the energy can be only consumed once by the laws of physics. Electricity, a terawatt hour can be consumed once, but it can be taxed twice as consumption. So something is wrong with one of these two laws. And the Parliament is waking up to this, the European Parliament, and it is asking to avoid double taxation. And the discussion about double grid fees is still ongoing, because then the question is more, do you serve the system or are you profiting from the system? If you profit twice, you should pay twice. But if you're supporting the system, you should maybe not pay twice. And then we see that we need new market products. We have seen the flexibility needs. And last year I presented a slide about the need to have over the day or even over the seasons the storage, but there is no, on the next slide please, there is no revenue for these products. There is no revenue today, there is no business case to shift electricity for 1 day or for 10 hours or something like this, if it's not in a specific situation. If it's not somewhere an island or an isolated system, then it's really very expensive. We see cases where it's happening on islands by replacing fossil fuel. Diesel will need to be transported. It's cheaper nowadays already to not transport the diesel and the fossil fuels and to build renewables with storage. And we have in some islands where it must even be flown in by helicopter. So it's really crazy sometimes. So there it makes a business case, but we need also to have products to bring electricity, to balance electricity out, because we want to move to a decarbonized system, and there's no incentive, no market where the players can bid into for this for the moment. This is something which we hope to change in the near future, because the carbon price alone is not rewarding enough. So we need to address this. These are the three main points I wanted to make. So on the last slide, then it's just to thank you. And we have we made last year Storage for You, a big campaign where we will where we showcase the added value which is used for energy storage. Thank you very much for your attention. If you have questions, I'm available.
Thank you very much, Patrick. We'll take some questions after our next two speakers. I'm very pleased now to introduce Dr. Imre Gyuk. After a distinguished academic career and having developed an interest in sustainability, Imre joined the Department of Energy. Since 1998, he has directed the Electrical Energy Storage Research Programme in the Office of Electricity, developing a wide portfolio of storage technologies for a broad spectrum of applications. I believe that it was his personal enthusiasm that resulted in the $185 million ARA stimulus funding for grid-scale energy storage demonstrations, which led to the development of numerous energy storage projects, including flow battery projects. He's internationally recognized as a leader in the energy storage field, and I invited him to talk to us about the need for long-duration storage and the role of flow batteries.
Hello, I'm Imre Gyuk, and I direct the energy storage program at the US Department of Energy. And I will talk today about evolving towards long-duration storage. And I have been involved in energy storage from the very beginning. The very beginning of commercial energy storage beyond pumped hydro has been in frequency regulation and in a 15-minute duration technology. We were doing this with flywheels, and after a successful demonstration with both NYSERDA and the CEC, we put together a full-scale facility of 20 megawatt of storage for frequency regulation. And this project provided the basis for FERC Order 755, which established pay for performance. And that was the beginning of commercially viable energy storage. So frequency regulation was picked up enthusiastically by many companies and utilities in the US and elsewhere. And since then, we and others have been engaged in building and validating business cases in resilience, sustainability, grid stability, and other topics of the type. These have mostly been in the 1, 2, and 4 hour duration realm. Designing a business case means that you're balancing the cost, which comes from the storage device, but also the power electronics and the facility itself, with the value of the storage system, which comes from multiple benefits such as arbitrage, demand charges, but also unmonetized benefits such as resiliency. And we've gotten pretty good at it. And in particular, we now have tools available that will do this almost automatically and give you an assessment of on your return on investment, such as the Quest program by Sandia and DOE, which is available on the internet for free, and which will tell you whether you have a viable project or not. Energy storage, increasingly over the last 10 years, has become popular in many states of the US, and the states have responded by putting in place appropriate regulatory structure, particularly on the West Coast and the East Coast of the United States. There are now regulations which apply to energy storage. And the projects are getting bigger. For example, at Southern California Edison, we have a whole host of projects from between 72 megawatts to 230 megawatts by various providers. And these are proposed to be ready by August 2021, although with the COVID epidemic, that may very well be a little bit later. Most of them are in conjunction with photovoltaics. All of them are for 4-hour periods, and all of them are lithium ion. So by 2025, we can expect 7 gigawatts to be deployed annually. This is quite impressive, and I expect that in fact it will be reached. One of the problems is that they will mostly be in the incumbent lithium-ion technology, and we have certain reservations about lithium-ion. One of them comes from sourcing. There is a limited number of countries that supply lithium and cobalt and other materials required for lithium-ion batteries. There are also sociological issues. The way these are mined in the ground, having little boys grubble out cobalt in Africa is not really acceptable. And we have ecological problems, groundwater use, for example, the vast amounts of groundwater use in countries that can ill afford using it in that way. There are safety problems. Fires have occurred, particularly in South Korea, but also in other countries, including a recent one in Arizona, which has been a serious problem in the development of storage in that state. And there are reliability issues. Lithium-ion degrades over time, and you cannot really expect a longer life cycle than about 10 years. And finally, there is reuse, recycling, and disposal, which really has not been resolved economically, unlike other technologies like such as lithium, lead-acid batteries. So we have some problems with lithium-ion technologies, and at the same time, we have a developing urgency for long-duration storage. 30 states, Washington, D.C., and 3 territories have adopted renewable portfolio standards. 7 states and 1 territory have set renewable energy goals. These are in many cases quite ambitious, between 50% and 100% renewables within 10 years or so. And if we're going to achieve this, we will require longer duration storage, because we are, after all, dealing with energy supplies that are only available, in the case of photovoltaics, during half the day, and with wind with some intermittency. So we will need longer duration storage, and not just the 1, 2, and 4 hour storage that we are accustomed to by now, and which covers short-term fluctuations quite nicely, but 8 hours, 12 hours, even days and seasons. Long-duration energy storage is essential for the development of a greener and more reliable grid. We can see the first steps already. At DOE, the ARPA-E program has its DAYS program. For long-duration storage. DOE has a Grand Challenge program initiative, which not only concerns batteries, but flexible energy like demand management. The California Energy Commission has $33 million in funding out there to explore new technologies behind the meter. And the California Public Utility Commission has called for 1 gigawatt of long-distance storage, which they define as 8 to 12 hours by 2026. The problem is, what is the business case for long-duration storage? With storage as we now have it, you require turnover. You really make money only when you charge or discharge, and you have to do this fairly frequently. If you're going to have your energy in storage for 3 days at a time, you will have basically stranded assets, and you will not have receive revenue. So we will need new regulatory frameworks which will set the stage for the business cases. So are we going to have mandates on providers of renewables? Are we going to have deep tax rebates? Who knows? It's a topic that is being explored very actively. But in any case, every step towards longer duration storage will require a new business case based on an appropriate regulatory framework. So what are the cost goals for current technologies when manufactured at scale? Lithium-ion batteries, we are told, at least the packs, will be as low as $100 per kilowatt hour. Vanadium flow batteries we have brought down to $300 per kilowatt hours, although that includes a certain amount of power electronics. Among the newer technologies, there is zinc manganese oxide with 2 electron systems, could be as low as $50 per kilowatt hour. We have low temperature sodium and sodium ion based batteries, which might go to $60 per kilowatt hour. And we have aqueous soluble organics, which are among my favorites, possibly as low as $125 per kilowatt hour. I like aqueous soluble organics because they will divorce us from the stock market, and it's entirely up to our ingenuity how low a cost we can manufacture these organics. And of course, we have advanced lead acid batteries waiting in the wings, could be as low as $35 per kilowatt, and the advantage there is that they're fully recyclable. And then we have technologies on the horizon. In the battery space, we can go towards better lithium-ion batteries, such as Inolith. We can go to liquid metals, Ambri, for example. We can go to sodium batteries as developed by MGK. We have interesting developments promised by Form, and we have zinc manganese oxides. And then, of course, there is a portfolio of flow batteries led by vanadium redox batteries, but also zinc bromine, iron chlorine, and a host of technologies coming up. Gravity storage, very simple, but an interesting option. You can just stack up cement blocks the way the Egyptians did the pyramids, or you can go to rail-based systems such as Ares is developing in Nevada. Or there is pumped hydro, which we are quite familiar with, but it has certain problems with in the environment. There's compressed air, a good technology of which we have two examples. There is cryogenic storage, liquid air being developed in Britain and elsewhere. Thermal systems with ice, water, but more advanced one with Estes and Malta. We could also go with vehicle to grid, perhaps not with individual cars, but certainly it's a possibility for fleets such as school bus fleets, postal fleets, military fleet, entirely possible. Or we can go to chemical storage such as hydrogen, power to gas, and ammonia. The problem there is that you waste a lot of energy in the transition in creating these chemicals and then in using them. And of course, any of those can be hybridized. So in conclusion, flow batteries will play a crucial role between short duration lithium ion and future long duration systems. But in order to find a successful path to market, they must be reliable, they must be low cost, and they must be recyclable. And the companies who are involved with them must have adequate financial backing. Thank you.
Thank you very much, Imre. And we'll come back to you for some questions during our discussion session after the next speaker. Joining us from London is Nicky Herbert. Nicky is policy advisor to the Smart Energy team in the British government's Department for Business, Energy and Industrial Strategy. Nicky will be telling us about how his department is addressing the barriers to the adoption of longer duration energy storage and the smart system. Welcome, Nicky. Please turn on your microphone and over to you.
Hi, everyone. Thank you, Anthony, for the introduction and for inviting me to speak here today. As you say, I'm a policy advisor in the Smart Energy team at the Department for Business, Energy and Industrial Strategy for the UK government. I work to remove policy and regulatory barriers to allow electricity storage to compete fairly against more established forms of technology. The scope of my team does not include electric vehicles, heat storage or markets of flexibility, which are all covered by other teams within the department as well. I'm here today, as Anthony says, to update you on the work that my department has carried out for removing barriers to storage, as well as our future plans. Could I have the next slide, please? Thank you. So to start with a little brief introduction as to why we're all here. I'm sure I don't need to tell anybody on the importance and the value of the transition of the energy system to a more smarter and flexible one. And the £40 billion up there is from research as system-wide savings from Imperial College London and the Carbon Trust. To enable this transition, the Department for Business, Energy and Industrial Strategy released in 2017 the SMART Plan, which is the Smart Systems and Flexibility Plan, and in 2018 a progress update to that plan. These contained 38 actions in which to enable the transition to a best-in-class regulatory framework for electricity storage. The actions focused on removing policy and regulatory barriers, providing clarity over the treatment of storage, reforming markets so that they recognise and reward the value of storage, and investing to support innovation in storage to lower the costs and allow those technologies to deploy. Government and Ofgem are now considering the next phase of smart energy policy, and we're taking into account our net zero ambitions, including how we recently legislated to be net zero by 2050. Could I have the next slide, please? Thank you. This slide shows how the different teams within the Smart Energy wider team fit together. So storage is focused on the infrastructure side. We also have buildings and consumers, which are looking at demand side response, the market flexibility team that I mentioned earlier, a data and digitalization team, innovation, and then alongside all of this, we have our ongoing flexibility analysis and monitoring. And all of these are working in conjunction to enable that transition. Can I have the next slide, please? So what have we done so far? So I mentioned that we had those 38 actions within the plan. We've currently implemented 24 of the 38, and we commit to implementing the remaining actions by 2022. I've listed here a few actions as examples of what we've done. So Ofgem consulted on the modified generation license for storage, and will shortly be publishing the results of that consultation. When finalised, this will enable the avoidance of final consumption levies to try and avoid the double charging, as mentioned in the previous presentation. It will also include the definition of storage and clarification around expectations for facilities below 50 megawatts. We've had the consultations on reforming the planning system, so this will remove storage apart from pumped hydro from the nationally significant infrastructure planning, and this will facilitate the deployment of larger scale storage, removing the 50 megawatt barrier, which was existing with the previous one. The government also has launched a health and safety governance group. This is an independent body run by, or chaired, by Joanna Cox of the IET. And this group is looking at how to ensure that as the deployment of storage increases, that the health and safety framework maintains being robust enough and future-proof. And an example of the work that it's doing is it's currently funded using with BEIS providing the funding, a gap analysis of standards frameworks being carried out by Fraser and Nash Consultancy. And then we have a few more options below. Could I have the next slide, please? Thank you. And so alongside our policy work, a really important strand has been invested in to support innovation in storage and helping to bring forward new technologies. And this slide contains examples of that innovation funding. So we have the £70 million to support smart energy innovation, with a number of competitions there shown, including the energy storage cost reduction, which did look at flow batteries. And we have at the bottom the £20 million storage at scale competition, looking to support large scale storage deployments of innovative non-battery technologies. And that recently we announced that one of the winners was Highview Power, which is going to be launching the largest and first, I believe, liquid air energy storage plant in the world, at a site in Manchester. On the right, just want to pull out from there, in the prospering from the energy revolution, part of that £102.5 million was £41 million went to the Energy Super Hub in Oxford, which used hybrid lithium ion and vanadium redox flow batteries, as well as smart energy systems and local area networks to look at managing the energy system, given the expected deployment of EV charging and also fleet management and such as that for Oxford. Could we go into the next slide, please? So what have we done? So those actions that I mentioned there, I've used to provide a certain level of regulatory clarity, but noting that we do still need to amend the primary legislation to define storage. We have removed several barriers, and we've seen storage start to deploy, and it's also starting to deploy in a wider range of markets. But as mentioned earlier, we do have more work to do, and that's what we're doing. And the basis of the next series of the two work are these two questions here. So are existing reforms to the policy and regulatory framework sufficient, most likely to result in sufficient deployment to reach our net zero targets? And is electricity storage able to deploy at every scale? and for every type of customer. And so, as we've mentioned on here, what we feel that we need to address is that though we've done a lot for grid scale storage, and that's where most of our progress has been, we need to start looking at the two extremes of the scale, that being domestic small scale and why I'm here today for the large scale long duration storage. And that kind of ties into that secondary question of can storage deploy at every scale and for every type of customer. Can I have the next slide, please? So this slide shows the 3 sections that we then pulled out to look at for further investigation. So we have the additional barriers, the facilitating deployment of domestic and small scale storage, and facilitating the deployment of large scale, longer duration storage. For large scale, longer duration storage, stakeholders have identified in our previous engagement that this type of storage struggles to deploy due to the high upfront costs, and that there are also concerns that the market is not fully valuing the services that this form of storage supplies. We do expect larger scale, long duration storage to play an important role in helping to decarbonise the grid further, but it's currently difficult for us to model and quantify the system benefits. And so that's really what we're wanting to focus on in this next stage of policy development. So I've highlighted in red on this slide the 4 questions that we are interested in analysing and looking at, and why we're reaching out to stakeholders to help us with. So these are quantifying the system benefits of this type of storage, as I mentioned, asking how challenges should be addressed in policy and regulatory frameworks, how to facilitate a level playing field against more conventional forms of generation, and finally, what innovation support is needed for this type of storage. By clearly understanding these questions, and I can get the information back, that will enable us to then develop the next set of policy from beyond the plan once the actions are implemented in 2022 and the next steps of that. Could I go into the next slide, please? So what we have here are the questions on this slide and the next one, which I believe the slides will be shared out afterwards as well. And these are the policy questions, and on the next slide is the innovation questions that we presented at a workshop on the 14th of May. And it's trying to flesh out the, in more detail of what we've asked for previously and what we've mentioned on the other slides. So as you can see, we're discussing about, again, trying to quantify the benefits and trying to find what the niche is for large scale, longer duration storage compared to the shorter duration storage. We're asking for why projects may not be viewed as commercially viable from investors, and again, competing with other forms of storage and for them against other more traditional forms of generation. These questions are just an idea. I don't want to feel if anybody is, I don't need to feel too limited by what they're saying. It's just part of getting that conversation going. At the bottom, I've put down our team email address where we'd love to hear your thoughts or suggestions as to how we can handle these. Could we go to the next slide, please? And so this is my final slide. And again, it touches on what innovation questions we raised in that meeting, talking about what areas should innovation focus on with some suggestions, what should the outcomes of innovation be, and how should innovation be best supported. Our plan over this next period is to undertake extensive stakeholder engagement so we can inform everyone under the next phase under SMART and use this to develop that policy. We're hoping to be flexible with this engagement, so we're looking at running other workshops or attending events like this, and also working with trade bodies and things in order to have more deep dive sessions onto specific issues. And yeah, I think that's just mine. Prior to, I just wanted to reiterate please do come and talk to us. The email address is at the bottom of this slide. Please feel free to send any information that you have along these ones. It's a really exciting time. There's a lot of discussions around the green economic recovery and things like that, which would be exciting to see the innovative technologies and suppliers taking part. And yeah, thank you for the opportunity to come and speak here again.
Nicky, thank you very much indeed for your contribution. Some points of clarification then, please, on presentations from you, from Patrick and from Imre. Imre, you mentioned that using aqueous organic electrolytes would free batteries from the stock market. Are you able to explain what you meant by that, please? Imre, you'll need to unmute your microphone.
Can you hear me?
We can, Imre.
Oh, excellent. Well, the problem is that most of the other forms of battery rely on material that is mined in some part of the world. And the cost of those materials fluctuates. Vanadium, for example, has fluctuated recently by as much as a factor of 2. If we are able to use organic materials, which we engineer ourselves, then the ingredients are simply carbon, oxygen, hydrogen, what have you. And how cheap we can make this depends on our ingenuity and our research, rather than the stock market.
Thank you very much. I have a question for Patrick. Patrick, it was becoming clear from the other two presentations that maybe long duration energy storage could be considered a strategic network asset. Do you think it's a network asset or a merchant opportunity, and what would be the best way of deploying that?
It's a tricky question, Anthony. I mean, energy storage has added values on the grid level and in other applications. It's not only grid. If you look at the applications which we are emerging now, which are remunerating most of the energy storage devices today, it's always system services and grid applications. That's what we see. It's very seldom that it's not linked to the grid. It can be peak shaving in order to avoid connection cost or others, but very often it is linked to system services. So I see the system services will continue to be the big driver. Again, there are still applications where this will be economic without system services. And then if it will only be on the ownership of the market, or also some cases where regulated entities will own this storage and use this storage directly for their applications, it's not clear. The clean energy package is very clear about that it should be an exception only, that it should be market driven, and that the market should take the lead. So this is what we will see, lead by the market, and only in case of failures you will see then the possibility that it will become a real grid asset integrated in the system.
Super, thank you very much. Andy, you're controlling our questions. Maybe you could summarize a question from Mr. Singh.
Yeah, sure, that's a good one. So I think this one's particularly addressed to Patrick, and that is grid codes and standards vary considerably across EU member states. Is there any initiative to harmonise those?
There are different discussions on this topic, and that's why we have now the battery regulation, which will give some guidance and some standards regarding materials recycling and others. Regarding, let's say, safety, I know that Senelec is looking into this. It's a point which was identified that the installation of batteries vary depending on where you are in which member state. So there are activities also to standardize this to avoid to have 27 different regulations. So to reply in a nutshell, yes, it is recognized. Yes, we're working on it. Did we achieve it already and can we implement it? Unfortunately, not yet. But if you want to join the discussion, I would encourage you to join either the association or the forum, the IFBF or whatever, to participate and help us to sort this out.
Super. Thank you very much. Thank you to all our speakers in that session. That was useful and informative. And I'm sure that if you've got further points, please put them onto the Q&A and we'll try and address them afterwards. Our next speaker this morning is Daniele Gatti. He's a technology analyst at ID TechEx. It's a company which provides technical and business analysis. Daniele specializes in energy storage technologies and applications and is also interested in energy harvesting. I've invited him to speak to us about the present market status for flow batteries and to give his opinions on future opportunities. As we are very interested in the market, I suggested his talk should be titled, "Who Pays for Energy Storage?" Daniele, welcome. Please turn on your microphone and over to you.
Hi, Anthony, and welcome everyone. I'm very pleased to be here today. I'm Daniele Gatti, a technology analyst at ID TechEx and part of the energy storage. So before starting the presentation, I'd like to mention just 2 points. First of all, in the presentation, there will be mentioned company's name. And as ID TechEx is an unbiased company, the reason of the mention the name of this company is only for the attendees to see what's the status of the market. And the second point is that these slides, as you can see, are interactive. So you have the hyperlink in the slides. So feel free to download and check more information. In the next slide, please. I will briefly talk to you about the ID TechEx. So what we perform at ID TechEx is making a technology assessment, mostly about emerging technology. And what we do is perform a market analysis by interviewing companies, when possible, visiting them. So the outcome of our work is writing our reports, besides performing subscription and consultancy project when required. Next slide, please. So about this presentation, this is extrapolated by the ID TechEx report about the redox flow battery. And what I would like to address today are 3 main points. So first of all, why, as already well highlighted by the previous speakers, why do we need the energy storage? Then what is the status of flow battery? What are mostly the main technology, and how will the market evolve in the next years? Next slide, please. So first of all, why do we need the energy storage? Well, this is mostly driven by variable renewable energies. So in the past years, we have an increased adoption of renewable energies, and the energy storage devices are quite a must, a requirement to stabilize the electricity grid and ease the adoption of these variable energy sources. Next slide, please. This is a brief description of the electricity grid structure for who of you is not very familiar with that. So the electricity grid structure is separated, let's say, in 2 big parts, the behind the meter and front of the meter. And as you can see by this description, there are batteries that can be applied in both segments, and they can provide different services and different ancillary services, which they help to increase the resiliency of the energy grid and to ease the adoption of renewable energies. So in the next slide, please. So as already like the previous speakers mentioned, there are different and several technologies involved in the energy storage. Here I wanted to focus only on 2 of them, of course, the redox flow battery and one of the main competitor at the moment, which is the lithium-ion batteries. As you can see from the table on the right side of the slide, the 2 technology are, of course, in competition between each other, and the redox flow battery has definitely some advantages in comparison with the lithium-ion batteries. So in the next slides, I will show you what are the current status of the market, or let's say main information about the vanadium flow batteries. what I call the Great Merge. It was the merging about the two main companies, two big companies, RET and Avalon Batteries, and the newborn company is the Invinity energy system. And this company has the capability to address all the spectrum of the energy storage market, from a small scale for a few kilowatt hour technology to a larger scale, to a megawatt hour scale. Next slide, please. So here, with this slide, I wanted to show what's the Schmidt Group. My apology to Schmidt Group for an extra T in the title of the slide. So Schmidt Group announced the joint venture with Nusanet Investment this year, and to build a 3 gigawatt hour manufacturing facility, which should start operation next year in 2021. And I think this is a very important information about the vanadium flow battery, for the reason that it shows how the market is moving from a small production scale to a larger production scale, and address like a wider spectrum of the market, while also reducing the initial capital cost of the technology. Next slide, please. One another important information was, of course, the VRB Energy, which completed the phase 1 of the 10 megawatt system in Hubei, China. And this is also another important project announced last year in 2019 to show how the vanadium flow battery market is evolving. Next slide, please. With this slide, I wanted to complete the vanadium part, the vanadium flow battery side, and I think it is worth mentioning the Bushveld Mineral Corporation. So Bushveld Minerals is a corporation made of the other two companies, Bushveld Vanadium and Bushveld Energy. The Bushveld Vanadium is involved in the production of the vanadium electrolyte, and the Bushveld Energy instead is focused on the promoting of the vanadium flow batteries, either in Africa, so Bushveld Minerals is a South African company, but also outside the African country. And Bushveld Energy is involved in the merging of RET and Avalon batteries, and also in the acquisition of the Enerox company, which is part of the CellCube. Next slide, please. So there is a very large interest in the battery as energy storage in general, not only lithium-ion, not only redox flow, but in general. And this was demonstrated by, for example, here just one case, the World Bank Group, which announced a 1 billion of funding in 2018, and next to this 1 billion, other 4 billion are expected. And these funding are expected to be used in small and middle income country, like sub-Saharan countries and Middle East Asia country. And so this to show where or how could be possible to, where is the interest to develop a more resilient grid. Next slide, please. So one of the questions that sometimes I've been asked is, what's after vanadium? Is there something that is, which is present in the market? Definitely what's after vanadium is the organic flow battery, as mentioned by Mr. Gyuk before. But beside the organic flow battery, there are also other companies which are dealing with other chemistry like zinc bromine, hydrogen bromine, all iron, and other chemistry as well. Here, I'm sorry, on the y-axis is the number of companies involved in this different chemistry. And in the next slide, please. As we will see, so there is an interest not only from a company perspective, but also as from the European Union, as Patrick Clerens has shown us before. The European Union, European Commission has funded almost like 70 million of euros in the Horizon 2020 project, only related on flow batteries. And as we can see here, the EU consider the flow battery in general prime candidates for grid-scale stationary energy storage, although at the moment the main technology is relatively costly due to the electrochemical material which is involved in it. And here I show you like 4 of the project which are currently undergoing. And if you will download the slide, you can click on it and see more information about them. In the next slide, please. I will want to show you a little bit about one of the other chemistry, the zinc bromine application. And here I wanted to show you 2 of these two of this company, the Australian Redflow and the American Primus Power. So both of them are kind of related to the front of the meter application of the grid, of the energy grid. And as you can see from the slide, the Redflow is mostly involved in telecommunication application in off-grid, while the Primus Power is involved in all of the front of the meter scale of the energy grid. The next slide, please. Here, in conclusion of this technical part, the organic system, here I think it's worth mentioning the project of the European Union related to organic system, the BALIT and IGRU project. And also very interesting was the cooperation with between like BASF, the chemical company, the German chemical company, and Jena Batteries, announced early this year to develop the organic flow battery, electrolyte related to the flow battery developed by Jena Batteries. The next slide, please. So to summarize my presentation, so here this is a current kind of picture of what's the current status of the energy storage market. Here I wanted to picture only the comparison of lithium-ion batteries and redox flow battery up to 2019. And the lithium-ion batteries are, of course, dominating the energy storage market due to several reasons. And here on the right side, you can see what are the announced lithium-ion gigafactory announced till the Q2 of this year, which is like from this slide is 290 gigawatt hour, although my colleague confirmed that this number is actually increased to a range of 400 to 500 gigawatt hour of yearly production. Of course, it has to be precise that these are not battery only focused on energy storage, but in general to several applications. In the next slide, please. So here, we see that the main competitor of the flow battery is, of course, the lithium-ion battery, but there are also other chemistry involved and other technology involved, like, for example, the hydrogen technologies, which we have heard about is like several times over the past months. And so what I want to picture here is that there are a lot of a high requirement to for energy storage devices. One of them for sure is the redox flow battery, which are at the moment, in my opinion, very competitive from a technological side. And what I believe is that in future, a wider technology diversification of the energy storage market will describe this evolving market. So in the last slide, please. So this is to summarize what is the outcome of our work is. So this presentation comes from our report. And if you have any further question out of this conference, I would like you to invite to text to email us at research@idtechx.com. And thank you again, Anthony, for inviting us to speak here at the IFBF.
Thank you very much, Daniel. In the next part of today's session, I've asked several speakers representing different companies to discuss the winning attributes for flow batteries. If we'd been in Dusseldorf this week, we would have gone to see the microgrid demonstration at the headquarters of John Cockerill. We chose this visit because it hosts a flow battery supplied by Sumitomo, one of our sponsors, as well as another flow battery system, a long duration battery system, and a lithium-ion battery. We would also have visited the headquarters of Volterion, a manufacturer of flow batteries. So joining us today is Francois Henry from John Cockerill, Thorsten Seipp from Volterion, Matt Harper from Invinity, and Alex Schoenfeldt from Enerox. I will ask each of them to introduce themselves very briefly before our discussion begins. First, Francois, please turn on your microphone and over to you.
Hello, thank you, Anthony. Thank you for the invitation. Good morning or good afternoon, everyone. So I'm Francois Henry. I'm a technical manager at John Cockerill company. I began to study batteries 10 years ago, starting essentially with lithium-ion for the automotive industry, before to be involved today in the other world, which is stationary storage application. I especially work for the energy sector in the John Cockerill company. So in this energy sector, we are different business line, and I'm involved in the energy storage business line at John Cockerill. So John Cockerill, it's a very old company with 200 years of story. It was founded in 1970. And for several years now, we are diversifying our activities in the energy sector, which was initially based on steam process, with mainly heat recovery steam generators, industrial boiler. And today we have other business line, including ours, the battery storage activity, and another one active in the hydrogen generation.
Super. Thank you very much. Thorsten, please turn on your microphone and over to you.
Hello, my name is Thorsten Seipp. I'm one of the managing directors of Volterion. Volterion battery stack and flow battery component manufacturer based in Dortmund, Germany. And we're funded 2015. We have about 35 people now, and we're supplying the flow battery community and industry with series produced flow battery stacks.
Super. Thank you very much. Matt, please turn on your microphone and over to you.
Hi, everyone. I'm Matt Harper, Chief Commercial Officer with Invinity Energy Systems. If you go on to the next slide, you'll see a picture of me. I've been in the flow battery industry for 16 years now, originally as in a technical capacity, but most recently heading up sales, business development, and marketing for Avalon Battery, and then following our merger with Red T, now holding that same role with Invinity Energy Systems. If you go on to the next slide, I'll just talk briefly about Invinity. We are a vanadium flow battery manufacturer with operations in Canada, the United States, and in the UK. We've got more than 10 megawatt hours of our batteries deployed to the field to date. Our goal is to make products and deliver products to market that are commercially proven, have very good cost characteristics associated with them, and many of the other benefits that I'm sure other people today will talk about in the flow battery space in terms of the recyclability, the durability, and sort of the safety of operating these systems.
Thank you very much.
I will leave it there.
Thank you very much. Alex, please turn on your microphone and over to you.
Yeah, thank you very much. My name is Alex Schoenfeldt. I'm with Enerox, which is the most, I think, famous brand CellCube, more known in the market. I'm in the industry now about 5 years. I started with Unicos, deploying lithium projects in the EMEA region, about 150 megawatts. I'm now with CellCube, Enerox, and if you just go to the next slide, I think what we are famous for is that we have more than 50% of all installed vanadium redox flow batteries installed globally in all kinds of regions of the world. So we have a very broad experience of field installations, of system behaviors, of impacts on the technology itself. It's about 20 megawatt hours what we have installed so far, mainly in the small scale area, 10, 20, 30 kilowatt systems, mainly in the CNI space or in the microgrid space. Now, as Enerox, we are going into the larger scale area. It means we want to actually support the market with our experience in understanding what is needed to go larger scale and then also get the cost down. So that's our main approach to the industry and how we want to support the community of getting understanding of what it actually become a bankable technology. I think we will discuss further things later on. Thank you.
Thank you very much, Alex. So I have some questions for each of you. So for Francois, please, what have you learnt from the flow battery installation at the microgrid?
So regarding our battery storage activity, we develop it thanks mainly to our own microgrid platform. So this microgrid is connected to our facilities and to the public grid, and we have different kind of ESS technologies. One of the most important is, as you told, the vanadium redox flow battery supplied by Sumitomo Electric. One of the reasons of our proving ground mirrors is to master the technology and analyze the behavior of the battery. So we make different tests in different ways, from standard performance test, let's say, that allows us to see and to define the exact performances of the flow battery in standard condition. And that demonstrates the specification sheet of the battery, the flow battery. That allows us also to apply our own standards. But the more important for us are the use cases that we can duplicate it on the platform and implement in our site. And that tends to confirm the adequacy of flow battery in many cases. We make different kind of tests. Some are on-grid test. So we make for sure combination with renewable energy, with the PV plant we have on our site to make our peak power. So we also test flow battery with different kind of typical services that we can do with the public grid. So for sure we see some differences between each technology. Each technology has its own characteristics. But the first we see on the standard test are very good for us. The efficiency which is very good, and we did as well off-grid test. The off-grid test we performed was at the beginning of this year and very encouraging, as we made tests from on-grid to off-grid with seamless transition. And this is very encouraging. So for us, the vanadium redox flow battery is a good product for a very large range of applications, especially for grids based on renewable energy. Even if there are still some barriers linked to cost of some part of this technology, we trust on it for the next challenge that will blow up in the next coming future. For long duration and especially for installation that have to last a long time, 20 years or more. But our application is not limited into the erection and supply of adequate control system for this technology. Today we take as well advantage of numerous expertise we have internally in our group by developing specific plastic tanks for the Sumitomo battery. So we trust a lot in this technology. For sure, we will be very happy to show you later during the next IFBF some detailed results. And I will be also happy to offer you a site tour of our microgrid platform next year. Let me finalize that if you are interested in, we rent our platform with services for large grid tests. So if you are interested, don't hesitate to get in touch with us.
Super. Thank you very much, Francois. It seems music to our ears when you say vanadium flow batteries are a very good technology. I think that's very encouraging for us in the IFBF to hear your enthusiasm as a user of a system. I'd like to turn to Alex. Alex, you've installed many flow batteries around the globe. What do customers really want from storage? and who are your competitors to getting your batteries on site?
Yeah, that's always a good question, because otherwise we would not meet the market requirements. There are 2 slides related to that question. If you can bring them up, that would be great. Starting with what customers want, I think we all know that customers are typically not well educated with regards to technology details. I think the question is, should they really? I think no. So I see typically 3 customer groups, which is starting top right is typically project developers or large utilities thinking in nowadays green power purchase agreements. So they would like to understand how they can provide large scale just energy and then power to utilities or regions, and they would like to have that, of course, at the lowest cost. So this is something which today is starting. You have seen this in the US, many 4-hour duration projects ongoing in the megawatt scale. And at the end of the day, we'll end up in a scenario where you maybe look into renewable baseload. I think today we can discuss maybe some daily baseload scenarios or some regional distribution baseload, but this is what they look at from that perspective. So project developers, utilities. Then you have a big group of asset owners, so IPPs or traders who would like to make money with their assets. That's typically then traded on the capacity reserve markets. And they just look, what is the value for money here? What can your storage offer? Which flexibility can you offer? And we see this now in some markets like the UK, where they move from 1 hour to now more 3-4 hours. And this is where then, for example, peaking capacity gets traded, and you have to offer this again at lowest capex to those IPPs or asset owners. And the last group is the ones which are more the kind of the direct users. So it could be microgrids, could be remote areas, could be industrial clients. Things like heavy duty cycling is something which they look at. So they have maybe some high peaks. They would maybe look into substitute their fossil fuel equipment. So that's something which I would call their use cases. And this is how they look into then the market, what is available as a storage technology, and what they look at is then the flexibility, the bankability, longevity at those costs. It's not more like, I would like to have lithium or I would like to have flow battery, whatever. It's more like, this is my use case. Please provide this at lowest cost. Some of them are moving into levelized costs of energy, which sometimes is better for the flow battery, but this is what they ask for, and this kind of price is the main driver. Then they look into performance guarantees, and they look into the bankable technology, which I think is one of the hardest hurdles so far. But we as a industry, as a flow battery industry, have to provide all the evidence required by lenders, investors, to provide those bankabilities. I think that's from a requirement perspective. If it's the next slide, that's what we see as a competition. I think it's lithium all over. So that's a kind of a comparison of the different technologies with the multiple elements, from duration sweet spots to warranted DoD. So the devil is in the detail very often. I think the lithium industry has been very good in marketing in a way that they show very often lowest cost in terms of kilowatt hours, but if it gets to applications and usability of the technology, there are as well things to be considered, including the augmentation part. I think so there are things which I think is important if we look from an industry perspective here. I mentioned the bankability. The investors have seen now lithium is bankable. We have to work on that one as well, but I think we shouldn't forget that there's still conventional in the field, and when investors are looking into the power supply and the energy supply contracts, and when they are about to invest millions of money, then sometimes the conventional is still the only reliable option, and we shouldn't be to kind of just always looking with the green glasses. I mean, it's great what happens in many countries, like carbon-free footprint, but we shouldn't forget there is a whole other things ongoing in the world where storage technology is not yet a given, or where even renewables is not yet a given. and you all know those plans of coal plants to be still built, other conventional plants to be built. So I think this is a long road to go, and I think these are really the competitors. I really think that we as an industry, as a flow battery industry, should be more closer together and work on helping each other to really move to the next level, rather than fighting about which flow battery technology is the better one. I think we all squeeze between lithium and hydrogen and the conventional. I think important is that we accept the market requirements and then move into those criteria, like the sweet spots or the levelized cost of energy, where I think the flow battery is if it's getting into 2-3 cycles per day as a 1C equivalent, maybe even 4 or 5, then we can beat all the others. I think that's something we should look at.
Thank you very much. It's interesting that you talked there about the marketing and the development of the market. I'd like to go to Thorsten. Thorsten, you've started a new company a few years back. You've obviously got a view to how the market is moving. Could you tell us how you see the market developing and how you're moving to satisfy market needs, please?
Yeah, so to be honest, we saw a slight dip in the redox flow battery projects in the last year because of the very high vanadium prices. But as now the prices went down again, we really see the market evolving again, and also many new players jumping into flow batteries, as well as the whole community growing again now. And also many people are really now getting more and more attention on energy storage, and then flow batteries have very special applications where they have big benefits against lithium batteries. And this is why we are really very confident that the market of flow batteries will grow rapidly in the next years. And this is also why we, as a supplier of components, are currently ramping up our production capabilities of our new stack generation 2 to a multi-megawatt scale, to just ensure that the whole flow battery community can be supplied by good and serious produced flow battery stacks.
Thank you. If you're saying that you're ramping up production, but you also said flow batteries have got special applications with an advantage, can you expand a little bit more about 1 or 2 special applications where you see that advantage giving market share for flow batteries, please?
Yeah, so I think it is very hard to beat lithium in the standard applications like, I don't know, frequency regulation, for example, where they really have a big market share and already cannibalizing each other. But we see applications where very many cycles are needed as very interesting for flow batteries, because there they can really have their capability of making many cycles in a short time, getting fast payback times of the application itself, and be just much more long-lasting than lithium batteries on the one side. And on the other side, we're really seeing that if there is long-term storage needed, flow batteries can have the lower capex and beat lithium in these applications. Thank you. So you're really talking here about selling the virtues of a flow battery as almost being indestructible and ideal for most customers. I'm going to turn to Matt. Matt, you just formed a new company by bringing together two famous companies in the industry. What are you telling the customers now that's going to encourage sales and increase production and make your company successful?
So, look, the thing that we have found is most useful to tell to our customers is compelling stories, compelling narratives around what this product and what this technology does. You know, especially in an industry where sales cycles are, you know, measured in, you know, not days to weeks, but rather, you know, sometimes months to years. Building sort of memorable narratives that people and customers can understand, can grab onto, and can sort of push into their own business is, in our view, the #1 way to increase the visibility of our product and our technology. You know, so within that context, I mean, we, you know, what are the stories, what are the narratives that we feel and we experience have resonated most strongly with those customers? And I think the three that I would point to is, first of all, talking about material successes, right? People want to know where you have taken your battery, where you have deployed it to a customer, and where you have helped that customer make money. And that, you know, that sort of proof of performance is stronger than any sort of, you know, technical demonstration or series of data sheets that you could throw at someone. The second, you know, story that we talk to our customers about that is, in our view, has been very impactful, is talking about flexibility of operation. You know, probably the biggest concern that a lot of the financiers standing behind the customers we're looking at experience is that this is a market that is changing so rapidly that they don't know if they're going to have the revenue streams available to them in 2 years or 5 years or 10 years that they're currently looking at. And so for us to be able to tell a story about, you know, a battery technology like vanadium flow that is inherently flexible in its operation, that it can operate over a very wide range of state of charge ranges and do either, you know, short duration discharge tens of times per day or long duration discharge over many, many hours, that flexibility and is something that they really value as they look towards their future business opportunities. The final narrative that we spend a lot of time talking about is around circularity. There's a considerable number of challenges amongst some of the other battery technologies regarding their environmental footprint and recyclability. You know, what we've seen is that our customers take a great deal of comfort in understanding that the constituent components of our battery are sourced responsibly, can be recycled at the end of life, and especially in terms of the vanadium electrolyte, can be reused indefinitely. So again, what do we tell them? You know, it's talking about successes, talking about how this battery is going to make them money, not only today, but in the future regulatory regimes down the road. And through all of that, making sure that the battery that they're deploying is going to be one that they can point to as a responsible, sustainable asset.
That's great. So just briefly before we break for a few moments, I could ask each of you in turn just to come out and talk about the key attributes that bring these benefits to customers. So I know that Matt's given us a few pointers. Which is the major selling point that we should concentrate on? Thorsten first, please.
I think cycle stability and fire safety are the best points to address for the customer.
Thank you very much. Francois, you're half a customer anyway, aren't you? Because you bought you bought several battery types of systems. What's the key attribute that you've seen? Francois, you're muted, I'm afraid.
Sorry. I said cost and yes, safety and long-term reliability. I guess it's the most important one.
Thank you. Alex?
Yeah, I see the longevity as the most important one for long-term investments. We still have customers working with the same electrolyte for more than 10 years with no capacity degradation. I think the world should understand that there is no need to waste technology and assets if they have a technology available which can last those 20 years without augmentation.
And Matt?
Yeah, the number one thing that we talk to our customers about is throughput. I mean, because it ties together concepts of cycle life, cycle duration, and calendar life. And those three things together are ultimately measured in how many megawatt hours you're going to get through one of these batteries over its lifetime. And that ultimately is going to drive people's investment decisions.
Okay, so all of you saw Imre's presentation earlier, and he was talking about 7 gigawatts of new storage planned for the United States. Personally, I don't really feel that that's an awful lot, because rumour has it that in the United Kingdom there's 7 gigawatts of storage that's in the planning pipeline. But do you feel that 7 gigawatts of storage in the US and perhaps a similar amount in Europe and a similar amount in Asia is a reasonable target, and how much of that would be accessible to flow batteries? Let's go the other way around. Alex, 21 gigawatts out there, how much can you get?
Alex, you're muted.
Alex, over to you.
Yeah, it would be great if we can, at the moment, get a very small portion, but I think we should address that in the next 3 to 5 years. We should also at least target the gigawatt level. I think following the Chinese example, I think we should be able to go for that as well.
No problems there then. Thorsten, what's your views on 21 gigawatt worldwide market?
I agree with Alex. If we can really get over this 1 gigawatt mark as the community, then we really already have a good plan for the next 1 or 2 years. And afterwards, if the technology evolves more, I'm very sure that flow batteries gain a significant market share, like more or less 10 or 20%.
Thank you. Matt?
I would say that number is a massive underestimation. We see a lot of individual RFIs, RFPs, projects being proposed that are on the gigawatt hour scale right now, and spread across large and complex grids like the US and Europe. Those opportunities are going to be, I think, a lot more frequent than people are really currently anticipating.
That's interesting. Thank you for your optimism. Francois, what's your view on this scale of the market?
It's quite difficult to say. Let's go first on the first steps and secure some first units, and take time to the technology to evolve. Let's say.
That's interesting. Okay, so thank you all very much for taking part in our discussion, and it's been interesting to hear your views.